Okay, so this is extending the idea of investing to earn money, but now thinking of it another way. Let's say we said we wanted to generate 25,000 rupees in 15 years for college expense for a child. So the parent decides at 5% per year, you can put it in the bank now at 12,000 rupees and keep earning. In 15 years, you would get 25,000 rupees because of this exponential growth. Now you slightly think of it the other way. You say something is going to cost you 25,000 rupees in the future, and it could be a climate damage. So you have to decide how much you have to invest now to protect against that risk in 15 years. This is in your own lifetime. So the interest rate that we talked about that we earn by investing now to get money in the future is we think of it as interest rate because we are going to get that money back. Whereas when you invest for the future expense, a cost in the future, so you're going to get 25,000 rupees and pay for the college. That was your idea. Here, you may be protecting against climate change, let's say a piece of forest, a water body, or something where you're not going to get the money. You're just investing to make sure that it doesn't disappear. So you have to put a value on it. It's maybe a non-market good, like the forest, which we talked before, has ecosystem services, food, fiber, medicine, cultural value, and so on, aesthetics. But how do you estimate the cost of a forest or the money you have to invest to protect a forest in 15 years, right? This becomes quite complicated. So in economics, you write that equation. We had written the interest equation this way, where we said we invest principal P, and in n years we want to get a certain return. So you can think of it the other way. What do we invest now for the future cost? And that depends on, again, some rate of growth per year, except in this case it's the depreciation of the money. So how do you think about it? Let's say let's use the example from Andy's book where he says you go to buy a TV and the shop offers you an option of paying 1,100 a year later or $1,000 right now. You can think rupees, dollars. I'm trying hard to make it rupees, but let's just stick to dollars, okay? Just to be consistent with the book. So the shopkeeper says you pay $1,000 now, or you can wait and pay $1,100 next year. So you have to calculate your own this value of money. So how much is 1,100 years in 1 year worth to you now, right? So some people will say, I would rather pay $1,000 now and not worry about 1,100. So you're basically not discounting anything. You're discounting exactly at 10%. So if you discount at 10%, 1,100 in 1 year is equal to $1,000 now. But if you're discounting less steeply, and you said my money would only discount at 5%, then the value would be higher than 1,000 now. So you would be very happy to pay that $1,000, saying you've saved some money by paying 1,000 instead of waiting for paying 1,100. But if you discounted it at a much higher rate, like 15%, then the value of 1,100 in 1 year would be less than 1,000 now. And you would think, wow, he's asking for 1,000, but for me 1,100 in 1 year is much less than 1,000 now, so I will not pay. I will just wait and pay 1,100 in the future. Okay, so that's typically how the discount rate works, and it is literally that difficult to define a discount rate, because It depends on how you discount the money. There's something called the time discounting that we just talked about. So somebody says they will give you 100 rupees next year or 90 rupees right now. You might say, I'll just take 90 rupees and do whatever I want with it because I can make more than 10% and make it grow more than 100 rupees in 1 year. That's time discounting, how the value of money depreciates with time at what rate. And there's something called growth discounting, which says that $1, 1 rupee is worth much more to a poor person than to a rich person. The example in the book is that if a billionaire sees a dollar bill on the street, he may not bend over to pick it up, but a poor person would happily jump on it and grab it because we value money based on our net disposable income, or whatever you want to call it, net wealth, right? So in general, when we say we will consume now and not worry about the future generations, we are basically saying future generations will be richer than us and they'll be rich enough to take care of themselves. So let's not worry about saving for them. This is time discounting, and you have to also add growth discounting and how that works. So you can look at that this way. So the present value of $1 of climate damages as a function of the year the damages took place. The calculation is shown for two discount rates. So instead of the interest rate where your money grows, we are now talking about how your $1 now depreciates into the future based on whether you assume a 3% discount rate or a 1% discount rate. So obviously if you assume a lower discount rate, money depreciates much slower. So the cost of present value of $1 of climate change as it occurs in the future shows that if you assume a 1% discount rate, then even the climate damage is happening as far into the future as 2300 Common Era. We are in 2021 now. Even damages in 2300 are contributing to the $1 you are investing now to protect against those damages. Whereas if you assume that the money is going to devalue at 3% discount rate, then you can see that by about 2200 the damages have no value. They don't add any value at present. So please read and make sure you understand what is being said. So let's say somebody says the total damage of climate change to the global economy is going to be $1 trillion in 2100, and the global community decides now we have to invest to protect ourselves against this $1 trillion damage expected in 100 years, right? So you can use various discount rates and come up with an estimate of how much is it worth investing now. And if the investment cost is, let's say, 100 billion, then depending on your discount rate, your own estimate of what is worth investing now may be less than 100 billion, in which case you may say, I'm not going to spend 100 billion, or you might discount at a much lower rate and the present value of the 1 trillion damage in 2100 could be much higher than 100 billion, in which case you would assume it's worth investing 100 billion to protect against $1 trillion in damages at 2100. Okay, so you can see that this is a very difficult thing, because first of all you have to decide whether you want to invest to protect whatever it is, the environment, the air quality, water quality, food production, etc. in 2100. I won't even be alive by then, so we are basically protecting it for the future generations. In general, the way the debates are going, it's obvious that we don't value the future generations that much, and we just assume that just like we are mostly better off than our parents, they are going to be better off than us, so they are going to be able to protect themselves, so we don't need to invest now. So we mostly discount the future in this way and hesitate to invest. This kind of leads to the idea of social cost of carbon that we talked about before in terms of power, energy production and energy sale, where we added the externality of emissions and cost to human health and other things, and we moved the cost of production and cost to consumers. Instead of just private cost, we added the social cost, and we produced less energy at a higher cost to keep the emissions down. Here, many different economic models are used to estimate the social cost of carbon in 2007 dollars for different discount rates, so 5%, 3%, 2.5%, and then just to show how uncertain these models are and how they do these calculations, here for the discount rate of 3%, the number of models that are in the upper 95th percentile of the social cost of carbon into the future are shown, just to tell you that you can see that here the average value is 121 million dollars for well, not million, just 121 dollars per ton of social cost of carbon, whereas the some models in the 95th percentile are at 330 dollars of social cost of carbon. So basically, social cost of carbon is a very difficult estimate, and US under Obama put it at $132 per ton, I think. But you understand that the social cost of carbon, as we said before, is how much additional damage is caused for each additional ton of carbon that we put in, because there is already background carbon. Each additional ton we put in increases the warming additionally, and that causes problems in terms of cyclones, sea level rise, heat waves, extreme rain, etc. So you have to estimate the cost of those things. So if you look at the value per ton, each ton produces additional warming. It's going to make more damage. So the social cost of carbon goes up into the future as the emissions continue to make an impact. So you can see that at 5% rate, social cost of carbon of $40 by 2010 in terms of the 2007 dollars. So you're sitting in 2007, you're estimating the social cost of carbon for 2010. This book is a bit older, but it's updated now, but you can imagine how the numbers change anyways. So it would be $40 in 3 years. By 2015 it would have been $44. 2020 it's not changed much here because of the various assumptions in the models, and by 2050 it is reaching $99 per ton in terms of social cost of carbon for a 5% discount rate into the future. Obviously, if you assume a lower discount rate, you have to pay more in terms of the social cost of carbon. So if you want to say it's not a big deal, then you use a very high discount rate or a social cost of carbon discount rate here, then you can reduce the future value of social cost by doing this. So that trick you have to do very carefully, because we know that the climate change impacts are serious already. So we want to pick a rate that is really appropriate for the warming rates, emission rates, and impacts we expect. So at 2.5% it would go up even more. The social cost of carbon would increase more, and the 95th percentile of the models that are projecting very high future social cost of carbon for the 3% discount rate go from average of 261 to 811 per ton by 2050. So the main thing you want to remember is that social cost of carbon is directly related to the discount rates, and this is often used as a knob to say what investment should be made now. And in the next chapter, when we go to discuss mitigation options, we will not talk much about adaptation. Adaptation is basically is preparing yourself in terms of infrastructure, sustainable agriculture, water use, health protections, etc., to deal with changes that are already happening. But you cannot say we'll keep emitting and keep adapting, because at some point adaptation may become impossible to deal with the increasing impacts. So you need also mitigation, and mitigation essentially means paying for reducing our impact on climate. And every time we say paying for it, it means discount rates. So we'll come back to that in the next podcast. Okay.